Okay, greetings, folks. We're going to talk briefly today about determining the numbers of solutions. Determining the number of solutions is lesson 6.2. And essentially, we're going to look at the slope-intercept form of a line. That's y equals mx plus b. Remember, I write, you write, I write, you write. In order to determine whether a system of equations has 0, 1, or infinitely many. Okay, so does it have 0 solutions? 1 solutions are all real numbers. That's what we want to find out. You'll just be able to look at the equation. Well, you might have to do a little bit of mathematics first, but that's the gist of it. So what does that mean? So if we take a look at, this is a really big picture. If we take a look at the different types of equations that we might come across. When the solution is no solution, that means we have parallel lines. Basically, it's saying we have the same slope for different y-intercepts. So it might be something like this. It might be y equals 2/3 x minus 6, and y equals 2/3 x plus 4. Okay, the slopes are the same. Our m's are the same, but our y-intercepts are all different. If that happens, that means, well, my slope is going up a certain direction. I'm on a certain y-intercept. They'll never touch. Sometimes we have different slopes and different y-intercepts. That's just what we've been doing all the way along, right? That's our basic equation. I don't know, y equals 3x plus 6, and, you know, y equals 17x minus 12. You know, is one solution. You graph it on there, and that's not what that is, but that's one solution. Okay. Sometimes they give us the same line. We've seen it before. So I might see y equals 3/4 x plus 12, and then y equals 6/8 x plus 12. If I reduce the 6/8, that's the same thing as 3/4. They just try to disguise it. This is a basic concept, how it's looking like this. It gets harder when you get older. So different slopes, same intercept. So here I might have slopes that are different. Let me just come up with a quick example here. You know, off the top of my head is always bad. So in this case here, I might have 1/3 x plus 2. Okay, in this case here, I have 1/3 x plus 2 equals y. You graph that. They're saying if I have different slopes, these are two slopes that are different, but we have the same y-intercept. This isn't it, but you know, it looks something like that. Okay, now, one thing I wanted to bring up to you is what if I had a graph where I had the reciprocal, the opposite reciprocal. If this is the case here, this would be a perpendicular line. But I don't think they have that in there in one of the examples that you'll be doing. So I just want to share it with you. If you have a case where the slopes are the same, or the slopes are the opposite reciprocal, if it's 1/3 here and it's the opposite, I mean it's negative, and then the reciprocal, flip the fraction, then it's a perpendicular line. But I don't know if we have those in this module. I don't think there is. Okay, so essentially what they want you to do is, like in example 1, they want you to find the number of solutions. Is it no solution, and it's parallel lines, 1 solution, or is it infinite number? So really you have to go through the process. Are the slopes the same? Are the y-intercepts the same? If the slopes are the same and the y-intercepts are the same, then you'll be able to make a couple of decisions. So if I'm looking at this example problem right here, are the slopes the same? No. B. Are the y-intercepts the same? Well, no, not really. So it's going to be a 1 point. That's all you have to do. Okay? So when you go through these, and I want you to go back and do the checks in a second. Go do the check. All right, do the check. And hopefully you got, I'm going to put an answer here. Hopefully you got 1 solution for that check. It's like duh, because they gave you an example of that. Here I have example 2. In this case here, same thing. Determine those different guys. They don't give it to you in the same format though, so you have to do a little bit of mathematics first, right? So if I have my 3y equals 2x plus 15, I cannot have a coefficient of a positive 1. That cannot be. So I'll go y equals 2/3 x plus 5. Well, if I look at this slope, it's 2/3, and this slope is 2/3. Well, the slopes are the same. My y-intercept is 5, y-intercept is 3. They're different y-intercepts. So in that case there, when my slopes are the exact same, but my y-intercepts are different, I have to go back and look at my chart. When the slopes are the same, but y-intercepts are different, it's going to be a parallel line. So go ahead and do the check here. Okay. Hopefully you found those parallel lines. Ahoy! Determine the number of solutions here. Same deal. I'm guessing it's going to be infinite numbers. Let's find out. So here is my slope here at 3/4. Now I have this problem here. I will go ahead and subtract 3x from both sides. So now I have a negative 4y equals a negative 3x divided by the coefficient. And I have y equals 3/4 x. Boom! It's the same exact equation. Therefore, it's all real numbers. Okay, it's all real numbers. Go ahead and do that check right there. All right. Now, they want you to do this. They want you to analyze. This is the big thing. This is what I'm kind of showing in this video here. They want you to analyze the systems of equations. However, that kind of cray-cray, they didn't give you the actual equation on the line. So you have to go through all this business here to get the actual line. Let me just take a second. Okay, sorry, I just cannot stand all the boxes. So essentially you have to find the slope first. Because we have to compare slopes. We have to compare y-intercepts. So we got to be able to find our slopes and y-intercepts. So I need a slope and y-intercept for line number 1. And a slope and y-intercept for line number 2. So let's go ahead and find the slope. I'll press pause of line number 1. And hopefully you got the slope to be negative 2/3. Double check your work if you did not get it right. I'm double checking mine right now. Yep, that is correct. Now I need to have the b. Well, wouldn't you know it? It might be interesting enough to know, but they kind of gave us the b, didn't they? Right there. So I'm going to put down 0.4. Okay. Now, I'm not cheating. They just gave it to us. I'm using the information they gave us. Go find the slope for the other problem. Alright, so when you did the math, let's see, I have a negative 7 minus 3. Did I write the problem down right? Oh, I didn't write the problem down correctly. Hang on a second. Excuse me. Excuse me. This is going to change things a little bit. It's right for what I wrote down, but I did not write down the correct problem. It becomes plus a positive. It becomes a negative 4/6 or a negative 2/3. Uh-oh. I'm sensing something here. This slope is a negative 2/3. Okay. Okay. All right. But we're not done yet, right? We don't have a b. But we didn't get lucky enough. They didn't give us any zeros over here. So now we have to find our b. To find the b, because here I could find the b because they gave it to us, but they didn't give us the b over here. I have to go back now and plug in what I know. I'll use this order pair here. So y is a negative 3. Our m is a negative 2/3. Our x is 3, but I don't know the b. Okay? We know everything but the b. Go ahead and find the b. Okay. I found the b to be a negative 1. So I put this back in. Press pause if you don't get it. But you put this math back in, the fractions back in, you do the math, you get b equals negative 1. So b is a negative 1 for the second one. So now I have this guy here. This slope here is a negative 2/3 with the intercept here. The same slope over here, different intercept. So what can you conclude about these lines? What do you think these lines are? These lines are, let's go back to our notes. Because, you know, if you can't remember, I can check our notes. We have same slopes, different y-intercepts, parallel lines, no solution. And if you put down parallel lines or no solution, I'll take either. But start getting the habit right now of writing no solution. They're parallel. That's what this means. Parallel lines, no solution. Okay. So go ahead and do that last check on page 336. Last check. Oh, this check here. I'll just show it to you. Do this last check right now. Okay, assuming my math is correct, and Lord knows I probably made a mistake, but that's up for you guys to find. If I made one, don't forget, you get extra credit. I found my slope to be a negative 2 here. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. The negative 4 divided by 2 should be a negative 2. That's my slope here. They give us the y-intercept at 0.6. I just put this into y equals mx plus b format. That way I could have an equation line. It makes it a little bit easier to compare. You know, whatever. Just I'm showing off. Okay. Here I have negative 1, negative 8, 3, and 4. Y sub 2 minus y sub 1. X sub 2 minus x sub 1. I got 12 over 4. That gives me a positive 3. I put that back into y equals mx plus b. I use this guy here. So negative 8 equals, the slope is 3 times a negative 1. That's a negative 3 plus my b. Add 3 to both sides, I get plus 3, I get -5. So my b is a -5. I put it back in. So this equation has 2 different slopes, 2 different y-intercepts. It will intersect at one point. If I wanted to graph it, I could, but we're not going to. All right, that is it for this particular module.